we have a video for you that will help you understand the following session better. Let's have a look at it.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
Okay, so as we saw in this video, the box robot represents our machine learning algorithm. So it recognizes the various patterns in our data. As example, in the dogs and the cats, it recognizes the patterns like the length of the tail of a dog, or the length and the width of the ears of the cat, and then accordingly it creates categories, and it gets to know what all things to look for in an image. Now, when we pass an image to predict, it checks for these patterns and then it gives the output accordingly. All right, we have a short game for you. So have you ever drawn something on Microsoft Paint? This is something similar to that, but here we have machine learning too. In the game of quick draw, we are given a topic or an object to draw, and when we draw it accordingly, the machine learning algorithm will predict it whether the object you have drawn is correct or not. So let's have a try on that. So for that, you have to open a browser parallelly. You guys can draw with me parallelly. So we have to create a new tab, and then in that you have to type g-co/quick draw. All right, so let's start. Okay, so the first object we've got is roller coaster. We have a time limit of around 20 seconds, and then I'm not good at drawing, so yeah.
Sorry, I couldn't guess it.
Okay. Similarly, we have around 6 drawings to draw, and the second one is arm. So
Sorry, I couldn't guess it.
okay, guys, so you have around 10 minutes. We can try that out and experiment with this.
I see necklace. Or bucket. Oh, I know, it's wine glass. I see bread. Or pond. Air pool. Air canoe. Oh, I know, it's hamburger.
Okay, so as you guys can see, whenever I draw an
I see
object,
line. Or
it checks
spoon.
for the patterns in
Or
this. Like
screen.
when I draw the pencil,
Oh, I know, it's pencil.
it saw the length of that and the pointed at the end, and accordingly it classifies like whether it's a pencil or not. All right, so here we
I see
draw
string
a
bead,
sheep.
or street light, or tooth. I see camel, or dog, or tiger, or cow, or crocodile, or newspaper. I see black cat, or cat. Sorry, I couldn't guess it.
Okay, so now let's look at one of these drawings. So if I check for wine, the top one is the one that I have drawn, and like the machine learning algorithm gets trained through a lot of data, and the drawings that are below shown are the drawings which were drawn by the previous people, like whoever tried these topics before, and it takes those data, it trains itself, and whenever the next time we try to create those objects, it checks the object drawing accordingly. All right, so let's move forward. All right, so how does this game actually work? So does anyone have any particular view or any idea on that? You can raise your hands.
Hello.
Yeah,
It's actually taking the concept of pattern recognition.
okay. Yeah, that's right. Okay, so does anyone else has answers?
Yes, it takes several images and see whether the image matches it or not
Yeah, you're right.
for accuracy and precision.
Exactly. Okay, so how does this exactly work is that we have a lot of data sets which contains the already drawn images, and with the data set we choose according to the output that we need, we choose a particular machine learning model, and to train that we input these data sets. While getting trained, it recognizes these patterns. Like if I draw a pencil, it will detect the length of that pencil and the pointed tip of these data, and after that, after the training is completed, uh, we give the testing data as input, and in that it checks for the same patterns, and if it finds that, it predicts that it is a pencil. Okay, so how could we program this? So we have a lot of machine learning models for this, and for different data sets or any different purposes we can use different models. Okay, so how does this ML work in quick draw? Let me give you an example. You can see a data set of carrots here, right? There are a lot of carrots. So the first step is the collection of data sets. So here we have all these carrots, and while getting trained, you guys can notice that all these carrots have a triangular shape common in all of these images. So that's can be recognized as one of these patterns. And the second one is a pointed tip or a bushy tip at the top, that can be as the second pattern. And the third one is the scratch marks or lines on the body of the object, and this can also be the third mark. And according to these three patterns, there may be more patterns, it depends. And so according to these patterns, it detects, like whenever after training, whenever give a input of any image, it will check for these triangular shape, these scratch marks or the lines, and then the bushy top. And if it gets these all these patterns, it predicts that it is a carrot. Okay, so what if we go by the traditional way of programming for making object detection or carrot detection thing? So in that, we have a set of first we frame the goal, like we need a carrot, right? We need to obtain the we need to classify whether it's a carrot or not. So for that we have a various set of conditions. The first condition should be length should be this much, and the second condition can be it should have these marks on the body, and the third condition can be the length of the leaf on the top should be this much. So in the traditional way of programming, we have a lot of conditions, and it would be become like it would become really difficult to code it. Okay, so now we go on to the current method that we are using for prediction. That is the part of machine learning. The first step is framing the goal of the product, what type of output we want. So here we want the carrots. So in that, we collect the data sets, and then we train the model using these data sets. So it will get to know what all things patterns are there, like the triangular shape and all what I said before. And after, there may be cases that mostly we may not get a particular output in a single training. So after that, we have to make some modifications and refine it by training it again. And after multiple trainings, we get preferred output. Okay, folks. So here we have a short quiz. So let's see everyone can answer this or not. So the first question is alphabetizing a list of song titles. What do you guys think? Is it a rule-based approach or a machine learning-based approach?
I think rule-based would be enough. We don't need machine learning for this.
It's rule based.
Okay, you can put it in the chat section. All right, so it's a rule-based approach, right? The condition here is like we should be sorting these song titles according to the letters. Second question, ranking web search results. What type of approach can we is used, like rule-based approach or machine learning-based?
Machine learning based.
Machine learning based.
Okay, yeah. So here we have both. Let me explain it to you. The first is the rule-based method. In that, we can take it as the number of visitors they have. Like the website A has a large number of visitors and the website B has a lesser number of visitors, and they both come under the same category. So whenever we search, we get the A first because it's more popular. And if we go by the method of machine learning, like if you take example of me, I search a lot about social media sites. So the machine learning algorithm detects that my category, what I search more is about social media platforms. So whenever I search something, it'll prioritize the options or the websites which has more similarity or more connected to the social media. So that's the machine learning approach. Okay, so the next one, predicting house prices based on location. So what could it be, rule based or machine learning based? Okay, so here we have the machine learning based approach. Okay, let me explain. So in this model, if we take a particular price in a particular location, it has a lot of parameters like the importance of that city, or it is the posh
Cost
area or
function.
not, and
Cost function will be right.
yeah. Yeah, so according to that, we have a lot of parameters, and based on that, we'll be predicting the house prices. Okay, so the next question is processing online payments. Uh, is it a rule-based approach or machine learning-based?
Machine learning.
Okay, so the answer is rule-based approach. This is because we have a particular set of rules for online payments. Uh, the first reason is like we have particular conditions like it should be secure. So we have exactly some set of rules through which it has to go to complete the payments. So here we go with the rule-based approach. Okay, another question. Classifying an object in a photo. Is it a rule-based or machine learning-based?
Machine learning based.
Yeah, you're right. So it's a machine learning based approach. So in this, we classify the images using different, like if we give sample data as the input data sets, and accordingly it will detect the patterns in a particular objects, and then accordingly it will predict. All right. So let's have a quick recap on rule-based approach and machine learning-based approach. In rule-based approach, we have a set of rules defined, rules as if separate conditions like condition A, condition B, C, it's all, and depending on this conditions, the result it will detect if it what it is. And in machine learning, we have patterns. In input data, the algorithm detects various patterns, and according to that, it predicts. So how to improve this? In rule-based approach, we improve by getting more improvised or like better algorithms. And in machine learning, we can improve it by having additional data or using optimizers. Okay, guys, we have a 5-minute break. And before that, if you do you guys any doubts?
Hello, Avinash brother. I have a doubt, brother. The searches in Google are rule based, na? Why can't it be machine learning?
It can be machine learning based. Like you're asking why is it machine learning based?
No, I'm asking why it is rule based.
Okay, it can also be rule based. Like uh, in a website A, like if you
The
go
answer
to
is you said it is rule based only.
for websites, it's both. Yeah.
Thank
So yeah, bro.
I think he means it for the payment one. No,
No. The website one I'm saying.
the website one is both machine
Okay.
learning and rule based.
Thank you.
Avinash,
Yeah.
like, can you just explain me why that website thing, like that, why the website thing is a rule-based one? Because I didn't clearly get your point.
Okay. So website searching can be rule based. Like if you go with Google, Gmail, and Yahoo Mail, Gmail is more popular, right? And Yahoo Mail is particularly less popular. So whenever you go for email, if you go and search for emails, we have customers for Gmail more. More people visit Gmail website. So accordingly, we have it will be ranked higher. So this is a rule based.
Okay, fine.
Okay, to add on to Avinash, I'll give one more example. If we take consideration of Google News, there, if it is a latest news, it is categorized with a rule-based approach. If we are looking in specific about one particular topic in the Google News, we'll be getting results from machine learning model. So that is the difference. When we search for one particular topic, Google is giving you customized results. Okay. If you want latest results, that's when rule based is applied. This is a simple example for both.
Okay, I got it. Thank you.
Hi Arya. So Arya has just posted a question. She's asking if there's only pattern recognition in machine learning. That's not the case. We do have multiple other machine learning algorithms that are used for specific purposes, and that's exactly what Nikhilesh will be covering in the second half of the session. So stay tuned.
So Avinash has explained about the differences between rule based and machine learning. So now we'll be discussing about machine learning entirely. So machine learning offers like powerful opportunities, but implementing them will come with a cost because they are complex compared to the traditional software. It is primarily because machine learning system is only as good as the data it is trained on. So now I'll be giving an overview of the process as well as important considerations that you should be taking while building an ML model. With to kickstart this, we'll be having an high level overview of what ML is. Okay.
A great business idea, and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has three phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
Yes, I'll be summarizing the entire video in 3 words. The first thing is data set. The second thing is modeling. The third thing is deployment. We'll be looking at all the 3 things in the next slide in depth. So, while designing an machine learning model or an application, we should have these steps in our mind. So, first thing is focus on the user and company's goals. And this gives us more insights about how to target people and how to get better data. Then the next step is we have to define objective. So this objective can be the success metrics or like quality metrics while we comparing the data's performance, data model performance. So the examples of few objectives can be like an application to suggest you new restaurants when you visit new city based on your past restaurant visits. So application has to predict what is your taste of food and it has to predict restaurants in the new city. So that can be one of the objective. It is an example. So next step is collecting data. Here, collecting data can be as simple as saying, but when it comes to production, it is very hard. And experts say that collecting, cleaning, and exploring data can be the longest, but it is most critical part of the process. So we should be properly collecting the data that is useful to our objective. Next thing is training and testing the model. Here we'll be using different types of machine learning algorithms and we'll look into the machine learning models like different types of algorithms in future sessions, but currently I'll be giving you an overview. So here we'll be training the model, then that model will deploy it and we'll see the results, how the real world data is affecting the model. And with the new data, we'll send it to the database. There, the database will again retrain the model and we'll be getting iterative models. And machine learning is very powerful because it is iterative in nature. It gets updated online. So that is a important thing. So as the time passes, the model gets better and better. It understands the entire picture of objective. So thing is uh,
Let's play a game.
the next thing is uh, human bias. So before I talk about human bias, I would like to give you few things why we are considering human bias while we're doing machine learning. So the first thing is humans are prone to trust the results of the computer. Only until it breaks down, humans will stop trusting computers. Similarly, machine learning, even the best ML model can sometimes be can sometimes be having issues. So and even biases. To resolve that, we need to have good data pipelines and stuff. So have a watch in this video, and the link for this video will be in the description as usual. So let's watch this video.
Game. Close your eyes and picture.
1 minute.
Let's play a game. Close your eyes and picture a shoe. Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game, where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
Okay. Okay. You have seen the video, and I would like to ask a question. What kind of questions that you would like to raise when one of your friend comes up with an application of machine learning? So
Yeah, I think the most predominant question would be what data set he or she is using, because that plays a major part in the predictions that his algorithm will do.
yes, yes, that is a correct answer. Along with it, I would like to improve that answer. We should even focus on the objective, because sometimes the objectives might not be a correct example, like a correct way of even creating an application. So we should even focus on the objective then the date where the data set is collected, how we try to reduce the bias, and where are we trying to deploy and get the new results. Okay, so that would be it. I'll be going to the next slide. Give me a second. So the next thing is ML privacy, and have a watch in this video. Okay, I'll be discussing after the video. I'll be giving few key points regarding the video later on.
Machine learning systems require lots of data to make successful predictions. What happens when that data is sensitive, such as people's names, credit card numbers, or medical histories? Sometimes sensitive data is needed to train a model so it can make accurate predictions. But at the same time, this data must be carefully protected. This is the challenge of machine learning privacy. Let's look at an example. Suppose you create a machine learning model to diagnose illnesses based on a person's symptoms. Someone who reports a stuffy nose and a cough might receive the diagnosis the common cold, whereas someone else with the same symptoms plus a high fever might be diagnosed with the flu. Plenty of other factors might influence the diagnosis too. Does the patient have a medical history of similar symptoms? Did she recently travel to another country or spend time on a farm with livestock? Are other family members or roommates sick at the same time? To train this model, you could feed it information about thousands of people and their symptoms, medical records, and demographic information. This data includes plenty of personal information that needs to be kept private. In addition, the data sets involved might contain other private information not directly relevant to medical diagnosis, such as patient contact information or the credit card numbers used to pay healthcare providers. What steps should you take to protect user privacy? Step 1 is to gather and select only the data that your ML system needs to achieve its goal. The less private data you have in the first place, the less you need to protect. This might seem like common sense, but it takes effort. It's easier to copy a whole database than to spend hours removing the parts that you don't need. Step 2 is to identify any data in your datasets that may be sensitive. For example, people's names, addresses, telephone numbers, email addresses, government ID numbers, and other personally identifiable information, or PII, should be kept private. Another type of private information is user-generated content, such as email messages, YouTube videos, blog posts, and any other content created by known individuals. Be sure to work with your product counsel to determine which types of information are considered private and how to handle them. You also need to make sure you have permission to use the data and whether the data has other privacy restrictions. Be sure to work with your product counsel here as well. Step 3 is to protect the private data. You can do this by controlling access to the data and your ML model, or by altering the data so it's not recognizable anymore, or both. Privacy is a critical concern in machine learning. When you maintain privacy, you build trust with users and protect your company's interests.
Yes, I would be summarizing this video now. The two, I'll conclude it with the 2 points. So the first point is, where are we gathering the data and what kind of data that we are collecting? So this question is very important. So this, like, more the data, more you need to protect. So that would be hard for a company to do it. So we have to reduce as much as private data and unuseful data. So we should strip down unnecessary data. Okay, that the second point is, we need to look into various country laws. Like India has different laws compared to US, UK, and other countries. So that's there. And the other thing that we should focus is even the company's policies. So we should focus on countries' laws and company policies on how to regulate the private data. So we should even think of even the compliance that we need to do in order to use these models in particular countries. Like if we want to use a particular application, machine learning based application in a particular country, then we have to look into that country's regulations. So we have ML privacy is a big thing while we are designing an ML application. And before we get into what ML do, we'll be having one interaction with all of you. So, do you have any kind of questions related to high level view of ML process or bias or privacy related to ML? So let's move on to the next topic. This is a more this is a very interactive section than others. So before I explain different wordings, okay, I have a question here. Why can't ML solve the captcha answers? It is not it's not yet that advanced to understand very detailed pictures. Like captcha has different types of capturings, different types of bus pictures, and like it's not that advanced in to understand the pictures in the captcha. So and recently I guess even captcha uh, can be broken down with AI. So that's the main thing. Like it's ML is not that advanced to in order to uh, classify a particular image out of like 100,000 objects correctly. So it will be a huge neural networks. So we'll get into how this classification and everything happens in future sessions where we do hands-on sessions. So before I explain all these three wordings, I would like to ask you guys, ask you folks, where what like the meanings of this. Like anybody can voluntarily unmute yourself and explain all these three things: artificial intelligence and machine learning and deep learning. Yes, Vishnu.
I know that I don't know that much. Just I know somewhat little. Can I say that?
Yes. You can, yeah, you can feel free to
But
answer anything.
in
Yeah.
artificial intelligence, both machine learning and deep learning will come. In machine learning, deep learning will come, and artificial intelligence is used in the chart chart in websites. It will be there. To understand to solve our questions, there will be chatbots will be there. For that, artificial intelligence will be used. For the machine learning to solve images, to identify the objects are used. And deep learning, I don't know.
Oh, okay. I'll clear all the meanings. So I'll give you a proper perspective about all these three things. So artificial intelligence, okay, yeah, it's muted. So artificial intelligence is a combination of multiple disciplines. Like it is having rule-based approaches and even machine learning in it. So it is a combination of multiple technologies, and if an application is based on trying to mimic human intelligence or trying to be smart, then it comes under AI or artificial intelligence. That is a simple example, simple meaning of artificial intelligence. But when we see into machine learning, it is purely based on the algorithms. So we have specific algorithms which learn on how to classify few things from data. So it is a machine learning doesn't have any kind of other things other than algorithms. So yeah. So when we look into deep learning, it is very similar to the machine learning, but it is unique. It is unique because it tries to mimic human brain, the structure of neural networks. Neural networks makes a complex application, classifying an image, like you asked, right? Like the captcha answers. So all these things like need neural networks in order to solve. So like here neural networks, they have neurons in them. So nodes which try to mimic the neurons in our brain. So that is why it is more famous, and it is widely applied in machine learning field. Yes. Anybody has any doubt regarding this? Because it is important to understand all these three meanings. Yeah.
Yeah, see, machine learning basically is we know that our model is basically learning and it's doing stuff. What exactly is deep learning? I don't get it. Like it's a
Okay, yeah,
broader
yeah.
spectrum of machine learning and it has like neural networks in it, like it, but I
Yes.
don't exactly get what it is.
Yes, I will I'll give you a clear idea about it. So machine learning here is like algorithms, right? Purely algorithms. But deep learning is also kind of algorithm, but it is unique because it is having this neural networks. So you can just think of as some kind of interconnected nodes where they have each layer has one particular algorithm. But where if you compare with machine learning, the entire machine learning thing is having one algorithm. But when you see inside the deep learning, each layer has one algorithm. So that is what differentiating between machine learning and deep learning. But deep learning is a subset of machine learning, and you will get more clear understanding about these two in like when we discuss about examples where it is applied and stuff. Yes. mm, let's
Okay, thanks.
A
okay.
small point, if you don't mind, can I just add to to the
Yes,
differences
yes, yes, yes,
between deep and machine
yes.
learning?
Okay.
So so machine learning essentially works on one level of features, but the feasibility with deep learning and why deep learning is called a subset of machine learning is that deep learning can work on different levels of features. So it can dive deep into the minute features. So that will give you more often than not, it will give you a quite an accurate result when compared to machine learning. But then of course it has its own backdrops as well. I'm sure we'll cover that later in the same course. Yeah, I just wanted to add that.
Yes, Vignesh, yes,
Yeah, I
we'll
hope I'm
be
not wrong. Yeah,
yeah, no, 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 yeah, yeah, that's a
yeah,
good addition.
thanks.
Let's move on to the history of machine learning. And so the first, it's like a timeline. So algorithms for machine learning were decided, like created more than a century back. These algorithms came from disciplines like linear algebra, statistics, then biology and physics. And it was at that point of time there was not any kind of computing systems, right? So it was not a possible thing to implement them at that point of time. And when we look into big data, so the big data appeared around like 1970 at that point of time, but it was not famous because the data which was getting collected at that point of time was low quality and the computation was not up to the mark. But addition to that was AI winter. So AI winter is a period where there was everybody were enthusiastic regarding AI or machine learning, but there was not that much of investment in it. So that was a period where it lacked importance or growth. So now we look into the third stage where the technology. So it is our present time where the technology has grown exponentially and even better algorithms for machine learning and very good data. So all of this are making machine learning in daily use cases like in YouTube and different things. So now we have discussed about history, right? So now we'll dig little deeper into machine learning, the types of machine learning. So yes, like machine learning algorithms. So the first thing is classification. It is a common application of machine learning. In this, the system determines which class or category an example belongs to. Here, if we look at this picture of a lion, classification machine learning algorithms can classify this as a lion or not a lion. And more generic machine learning algorithms can even classify them as lion or tiger or anything. So and these classification algorithms are like depend on a threshold which is set by human developers. So like if you build an spam classifier, it would be necessary to fine tune the threshold so your system didn't incorrectly label an email as spam when it was genuine. So when we look at this sigmoid function, on we'll get into all the sigmoid functions and different kinds of activation functions later on. I will just tell this is a sigmoid function. Here we can see that the threshold which was set along x-axis and y-axis was by a human developer in order to classify all the examples properly or have the better accuracy. And we can relate classification to simply a word called classes. If there is anything called classes, then we use one of the classification algorithms. So the next thing is regression. So regression systems output a number. For examples, how long it will take to drive from point like Mumbai to Chandanagar. So and other example can be how like what is the likelihood that someone will click an ad. So here the distance is in some kind of range, right? Some it can be some 800 kilometers or something. Here when we look at predicting that user can click on a ad can be from 0 to 100% as the probability lies in that range. So whenever range appears, it comes under regression problems, and we'll look into like in-depth explanation of all these types later on. But I'm just giving a high level view about all these algorithms presently. And the next thing is clustering. So clustering is a very important thing that we use in machine learning for specific tasks. Like if you see here, this clustering algorithm is trying to cluster handwritten digits. And another practical example is Google News, where the clustering takes place, like different types of categories like technology news, then global news. All these things are getting clustered based on the content present, like some keywords which describe their different types of categories. Like if they say some international, it comes under global news, something like that. So and I will be giving you currently a live demonstration of how this handwritten digits exist in a 2D like 3D space. So can everyone see the application here?
Yes.
Yes.
Yeah.
Okay. So here it is an application from TensorFlow. It is called Projector. So you can access this thing from the link provided in the chat box. This it is you can access this from projector.tensorflow.org. So as you can see here, all these handwritten digits are from MNIST dataset. So like you can see that ones are closely related to two, but here ones are far apart from zeros because the structure of 0 and 1 is totally different. So that is like this is how the clustering takes place. This is just a 3D space, like three-dimensional view. But if you think about like larger applications like Google News, it will be in n-dimensional space, like high level view that we cannot even visualize it. Okay. So in this example I'm showing this, you can play with this later on, like we'll be having all these links in one place, so it would be easy. Now we'll continue with other types. So the next thing is sequence prediction, and I think that everybody would have used the sequences like the pattern matching in your Google keyboards. So here you can see that based on initial inputs, the machine learning model can predict the future keystrokes. Like it like here machine learning is used in order to get proper predicted and customized results. And you can relate sequence prediction to the YouTube videos that you watch. So there new suggested videos can be based on your past videos. Like if you watch more videos on games, then you will be getting more videos on games, something very similar to that. It gets customized to your past, like whatever you see in the past, it'll get customized to that and predict the new videos or suggest new videos. So this is the last type. This is called style transfer. Okay. Or other name is generation. Okay. So in this we have used like in practically we would have used something like filters, right? And when we take a selfie and we apply some kind of filters, some monochrome or different kinds of things. In this example, a tortoise image is getting transferred, like the style of this image is getting transferred to something like painting here, the waves. So the output image, you can see that the image is getting it got transferred to something like waves of the ocean. So this is a example of style transfer. When one form of data is getting converted to other form of data, that's where style transfer is being applied. So here one more example, like the data, like male voice is getting transferred to with like will is getting merged with female, and machine learning is trying to uh, predict trying to make a new form of voice. So this is where different kinds of applications come. So to generate new faces, generating new voices comes under style transfer. Okay, I think I have explained a lot. It's now time to have an interaction with you guys. So this is with you folks. So this is the first question. So start you can have this answer in the chat box, or you can raise your hand in order to answer it. And if you know more about it, you can even give an explanation about it.
I guess it is sequence prediction.
Yes, you answered it correctly. And the answer, why it is a sequence prediction, because when we look at Play Store, as I gave earlier, when you download games, and the future games will be based, like the future predictions will be based on your past purchases. So here, best example is Play Store. That is why it is a sequence prediction. So the next one. Now I'll be taking from the chat box. So have your answers there. I'll be selecting someone so they can unmute themselves and give an explanation to that also. So that would be better. And
So we have to select, like we have to label those emails as spam and not spam. So we have a binary classification, like yes or no thing. So we'll be getting a huge data of emails, and we have to classify them as whether they are spam or not spam based on the words in it or like that. So I guess it is classification.
yes, yes, as I mentioned earlier, whenever there is some kind of classes, here the classes are spam and not spam. So only two things that we need to predict. So that comes under classification. Okay, now let's go to the next question. That is identifying trends amongst a group of people who have bought a new music release. So as I can see that answers are based on clustering and regression, but the answer is on clustering. And I'll give you an example, because here we are talking about groups, right? So whenever the term groups or something similar to that appears, it means that we are trying to place them in some kind of group. Okay, any kind of topic. Here it is music release, right? So here in music releases, it means that different types of music are there, right? Pop music, electronic music, EDM, and other kind of other types of music. So here it's like different types of grouping is happening. So that is why we are taking clustering.
Why can't it be regression when regression comes into picture?
No, no, regression, it's like a range, right? So here we are having different kinds of domains, because sometimes it can be a combination of few music types, right? That time it cannot it cannot come under classification, and it cannot come under regression, and I can say that it will surely not come under regression, because it is not talking about a range, it is talking about group of people.
I would like to ask something here,
Okay.
because on that, why, like, I also have the question, why is it not regression? Because
Yeah.
I'll give my explanation that since like you have so many categories of music, like you have rock, pop, EDM, whatever. So like somebody has released a music which is like a combination of other genres. Like there's jazz rock. So now
Yes.
the person who's gone to buy that, it's not necessary that he'll be having rock, but it's possible that he'll have only jazz, or it could be the other way around, or he could like both, or he could like something else. So couldn't
Yes.
isn't this like
Yes.
a range?
No, no, no. It is not. It will not come under range. That is why I have given an demonstration of this handwritten digits, right? So here we have 10 different types of digits. So sometimes this 2 and 7 can look similar. So they can come close to each other. The same thing is happening here when jazz and other type of music have similarities, then it goes into a group where they have similarities. So like here it can be to say that they come under like one kind of music is hard, so that is why we group different types of music. So did you get an answer for this? Like regression, it's like it will not come under regression because it regression tries to solve problem of range. So if there is some example you need a value in between 0 to 100, it gives you a value between 0 to 100.
Yeah, okay, I got it.
Here we are talking about groups, right? That is why it is clustering.
Mm-hmm.
And
Since it's people, that's why we can't put it in regression.
and yeah, and it's not it will not come under classification because here sometimes the classes can get merged in this
Yeah,
type of question.
classification, I know why it can't be.
Yeah,
I was
yeah,
just
sure.
asking why it can't be regression.
Yes, yes. Okay. Yeah,
I got it.
it's nice to, yeah. So the next question, we'll see in the chat box. So what is our answer? Like captioning a video, something like a YouTube video, right? So where there is an automatic captioning for a video. How is it done? Or video or on audio? Anything it can be. So what is it? Okay, style transfer. Yes, I will. Yeah, the answer for like the explanation for style transfer, because when the type of data generated by the system is different than the input data, then this is an example of style transfer. So as I told earlier, when one form of data is getting converted to other form, then it is under style transfer. So what about this? Can I have volunteers in speaking up and giving the reason for this thing, for this question, like why one particular type is can be applied? So anybody? Okay, it is like determining workout activity based on phone movement, right? So here we can see an example of like while jogging, it detects that it is jogging, and Fitbit and other devices use few things, and yes, it tries to predict the movement, like predict the one particular type of thing, right? So what is it? It comes under what?
Classification, I guess.
Uh, why do you think it is classification,
Mm,
Vignesh?
most probably because it is trying to label it on the basis of how the phone is moving. So if it detects a particular movement, it would label it under that particular. Assuming it's a supervised method, it would label it under one class. So that on that lines, I guess it could be classification.
Yes, yes. So
Uh,
here, yeah,
can I say something to this?
yes, yes, you can.
Yeah, I feel like this determining workout activity based on phone movement would be rather ambiguous because, like, it depends on how you're moving your hand or where you've kept it. So each person's jogging movement or walking movement or whatever will be different.
Hmm.
So I don't feel that it should exactly be classification because
Okay.
there'll be a range and it also needs to predict like what that guy is doing. So I
Yes, yes, yes. That is, I want to give a better explanation to that. It's it is a classification because here we have few classes like jogging, then playing football or any kind of sport. So here we have only limited number of classes, and it cannot be combination of classes. Like we can't jog while like it's a football is a different task compared to jogging, right? So here we have very limited
But
number
if
of
you're playing
classes.
football and you're running,
Okay.
it'll say the both as the same. Like it won't be able
Yeah.
to identify
Yeah.
which one is which.
Yeah. Correct. But here
Football
machine learn.
and
Yeah.
yeah,
Okay.
football
Continue.
and jogging don't necessarily come under running. The majority of both the things are running, but when you look at jogging, it is usually in straight lines or in regular circles. But when you're playing football, it's not so. There are a lot of irregular movements and there are a lot of reflex related activities. I think that's why it could really classify it under sorry, it could classify under jogging and football, because I we really don't know on what grounds this phone movement is being recorded. So until we know that, we can't be for sure. But then I feel
That's
this
exactly why
could
I'm
be an answer.
saying that it's ambiguous and cannot be put exactly into
And
classification
yes, yes,
No,
yes. I
because we do
wanted
not
to.
know what type of movement would exactly occur.
Hmm. Yes, yes. I would like to add one more thing. Here, machine learning is very flexible because ML can understand unique personalities. The way a person walks, like it can be different from others, right? So it is kind of it comes under something called online learning. So it will be learning while it is collecting data and predicting. So everything will go simultaneously. That's where the ML power is shown, where it learns all the time. Like it'll be learning about the user. So did you get did your answer get
Since
clarified?
it's for since it's for a particular person, that's why it can be put into classification. Okay.
Yes, yes. It's not for
Yeah.
whole. Yeah.
Yeah, it's not for whole. The phone would only belong to one person. Yeah, right.
So the next question is predicting the strength of a password, and this is a little tricky one. And yeah, so try to figure out which.
Is it sequence prediction?
Okay, and let's hear with for like let's
It
hear
comes
others.
under style transfer also, I guess.
Bro,
Okay,
it comes under sequence production.
okay, okay. Have your answers rolling out in the chat box also. We can get more participation and more ideas flowing. So and you can guess like it can be a combination of different things also, like two different things can be applied for this problem. So have a guess. It's not only one, it there are two.
could be regression also, I guess, to some extent. I'm not sure.
Yeah, okay, okay, yeah, yeah, correct. Like we'll look into others answers also. Yeah, anybody who
I
wants to.
feel that there will be regression in it because the password length is a variable.
Okay, okay,
Yeah,
okay,
regression will be in it. Regression will be one of them also.
okay, correct. Okay, let's
It
hear
might
one
be
more
regression because they have
But
range also, like number of numbers in that.
okay, okay, like there is a confusion here. So if you want to talk, please raise your hand so I'll pick one and you can answer. So Supreet has raised his hand. So you can unmute yourself and give your answer or guess the answer, bro, and give a reason for it.
Sure. Like according to me, I feel classification is the thing for this type of application, that is predicting the strength of a password, as the sentence says predicting. So predicting in the sense we are going to classify that particular type of password, right? Like whenever you go to a website and when you go for registration, it asks for a password, right? In most of the cases. So at that time, when you type some password, so you may get some options like this password is not that strong, it is a medium password, or it is a very, insecure password. So I think according to those classes, I pursued a classification for this type of the
Yes,
application.
yes, 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 yes. I would like to combine two answers here. That is wait, I'll just update the answer. So it we can use classification and regression. I'll give you the reasons for two different things. So here classification because some systems are trained to detect only classes, few classes like weak password, moderate password, and strong password. Here only three classes are there. So it is for some applications they try to reduce the level of complexity and they'll keep only three classes. That's where classification is used. But few systems need more security, so they implement regression models there, where the output will be in some kind of range, like saying like your password is 50% stronger than others. So here 50% is it is in the range of 0 to 100. So that is why it is also a regression. So that is why we have two answers for this question, and it is a good example for different
I have a question.
syntax. Yes.
Can it be sequence prediction also? Because like weak passwords usually have lowercase or without any at the rate symbols or any other symbols or without numbers.
Yeah. Hmm.
Can we like say that a sequence like these type of things will make it a weak password?
Yeah. Okay, I'll give you an answer for that. So it is not sequence prediction because in sequence prediction, based on the past things, it'll predict the future letters. So for entering a password, we don't need some system where it predicts the next letter, right? We need some kind of a system where it says your password is better or some kind of range. Because in sequence prediction, it is like in sequence prediction, as you can see in Google keyboard, when you start uh, what is it? Swiping on the keyboard, based on the initial letters and where you're trying to like use your finger, it detects all of this and predicts what kind of word you are trying to type. So okay, is your doubt solved?
Yeah, it is. Thank you.
Okay, so someone raised their hand. Do you have any question? Okay, it is Varun. Okay, you can unmute yourself and ask, or you can ask your question. Okay, Varun.
Yeah, I was asking whether clustering also can be a part of this. Since suppose, for example, 12345 6, it's a very common password, and people often tend to keep it, and it's a weak password. So it's like a cluster of 12345 6.
Yes, Varun, I'll give you a better answer for that. It is because these passwords are so dynamic that it'll be changing. Like presently, it might be 12345 can be used most, but when you see in future, it might not be 12345. It can be password, like the word password. So it'll be always changing. So to use clustering, it is hard to upgrade it to future versions. When we have classification and regression, when we have new data, we can retrain the model faster compared to clustering. Clustering is like when we have what do you say, if you have like hand digit data set where all the hand digits are already they are not dynamic, they'll not be changing. So they will be changing to some extent. Like I'm talking with respect to time. So with respect to time, this passwords, like the usage of passwords will be different. Okay, so you get the answer, Varun? Okay. Okay, did
I'm
you
not.
get it?
I wasn't able to unmute. I'm sorry. Yeah, it's. I
Okay,
got
okay.
it. Thanks.
Okay. Now let's move on to the next question. So identifying famous landmarks in a photo. So have your guess or have your answer in the chat box. Okay, we have a lot of responses in the chat box. Okay, Bhuvanashri asked a question that is like, can we have a rule-based approach for determining the strength of a password? Yes, we can have a rule based approach, but it is a tedious process because we need to have a lot of if statements and we need to keep improving that if statements. That for a human, it is very hard. Imagine if a system is there which can learn different types of uh, passwords, then that would be more easier, right? So, like one person cannot solve like majority issues like with using rules. That would be a very, very tedious task if you are using rule based. I hope it is resolved, bonus that question. And can we use regular expressions for rule-based approach? Yes, we can. Like no. I don't like it is not preferred, and nobody uses regular expressions for that.
That
Okay.
was actually the answer. We can use regular expressions for classifying the passwords.
No.
If you
Here.
if you use if you use a rule-based approach.
Oh, okay. I am not like
Yeah.
that much familiar with rule-based approaches, but
Yeah,
yeah,
I
that
have
that
actually
might.
done some I've actually done some work with regular expressions, so I know that it can be used, but as you said, it's really tedious. The
Yes.
thing is
Yes.
that I did not want to incorporate a machine learning model yet because I'm not that familiar with it. So what I was working on, I used regular expressions in it instead. And using it with Python, it's actually pretty okay. But the thing is that I had to put in a lot of criterias. So that becomes pretty long. Since it was Python, I was able to incorporate it. However, had I used in language like Java or C++, my code would have been huge. So
Yes, yes.
that's why.
Yeah. Whenever you have a problem which can be solved with rules, you have to use rules, because implementing ML everywhere will be a unnecessary and time taking and money also, right? So the computation, sorry, the computation is huge. Okay, the answer for identifying famous landmarks in a photo. Okay, I think it's an easy answer, and almost everybody, predicted that correctly. Not predicted, mentioned it properly. So the answer is classification, because here we have limited number of landmarks, and only the new landmarks will be coming, like we'll be updating the data set very later on. So as of now, we'll be having limited number of landmarks, and when we have limited number of classes, then it comes under classification, because it can determine the one particular class properly. Anybody has any doubt with this thing? Because we have a very limited number of landmarks, and we don't have a range for this, right? It's a count of landmarks. That's why we
A
are
lot of
using
people
classification.
answered clustering, so I want to hear their explanation on why they answered clustering.
Yes, anybody who wants to have like your opinions on clustering, you can raise your hand so I can pick one. Anybody? Okay, Varun. Yeah.
Yeah, I thought it'd be clustering because it's like suppose we take for example Eiffel Tower and Statue of Liberty, just for an example. So these two, it's like we can have a data set wherein you have a cluster of all these landmarks. So that's why I thought it's clustering instead of classification.
Okay. Yeah, yeah. Okay, Varun. Yeah. Okay. Yeah. So let's go
Can
into
I
the.
add something?
Yes, we can add.
Yeah, so why classification instead of clustering is that usually classification and clustering are quite stark in quite very opposite concepts, because classification usually has names to it and clustering usually does not have names to it. So when you're looking at famous landmarks, we usually know what the landmark is, and there is usually a label to it. So that is why I feel it comes under classification and not clustering, because we already know that these landmarks exist and this is what they look like and this is where they are at. So that's why I feel it should come under classification.
Okay. Yeah, nice one. Okay. Yeah, nice explanation. Ye- Okay. Uh, let's go to the next question. That is suggesting spelling corrections. I know that most of you know this thing, and I'll jump right into the answer, and that comes under clustering, because here here clustering we are using clustering because clustering can identify a particular spelling mistake by placing them in the three-dimensional space, or like three-dimensional view, so they can get the closest words related to that mistake. Like, if they, like, I'll give an example. Like in English, uh, we have something called avocado, right? And in France, we have something like avocat. So they almost sound similar, but when we look at their spellings, it is little different. And a machine learning model can understand they are similar, and they can suggest the word avocado or avocat. So that is why it is clustering. Okay, anybody has any doubt or?
Yeah, in MS Word, when we do that, we do that word check, it has machine learning incorporated into it, right?
I'm not that sure about it, but I'll give you that answer, or like I'll do my search and I'll give you that answer. But I'm not sure like it is using ML over there.
Because that thing is highly accurate, except for a few Indian words, it's able to
Yes. I'll
predict
get back.
everything.
Yeah, I'll get back to
Yeah,
your question
yeah, yeah.
in
Fine.
day after tomorrow's session.
Yeah, yeah, sure.
And I have one question.
Okay.
So in the previous one, when you said the classification of some other thing, you told sequence prediction is for like getting to know if you type something and it predicts the word and it suggests corrections.
No. I meant that sequence prediction is something like if you write, if like it's not to like our objective there is not to predict the letters. Our objective was to classify them or give some kind of percentage of how strength it is, like how strong it is compared to others. Our
Yeah,
objective was not to predict what they'll be typing in the password. So
yeah. But here in this case, we are trying to predict what the correct
no.
thing
It is
is.
like already completed word, right?
Oh, okay,
It
okay,
is. It is not. It is not like we are not predicting it.
okay.
Okay. So the next question,
So,
predicting the call. Okay. Yeah.
I didn't clearly get your point. Like, why did you mean clustering for specifying spelling corrections? Can you just repeat it again, whatever you told?
Okay. So like, don't think clustering with like with an example of like hand digit data set, because this problem statement is different kind of clustering compared to that. So like when you look at avocado and avocat, all these different words, like ML can understand their similarities. Like when like we can feed ML model a big data set, and it can understand where that word is being used, how it is being used, and to what it is being used. So like based on all these three different questions, it tries to figure out most suitable correction to that word. Okay. Hello.
Okay, got your point. Thank you so much.
Yeah.
Excuse me, sorry for interrupting. I
Okay.
feel it could be a combination of a sequence prediction and regression over clustering, because you said that okay, it clusters, but there is also a format wherein there are several words which are really close to each other. Say you told avocado and avocado are really close to each other, right? So there, how does it determine whether a particular word is going to be avocado or avocado based on the clustering? It might
Okay.
take it
Yeah.
wrong.
So I'll give an explanation to that. It is because here we are not feeding the model just these particular words like avocado and avocado. We are giving a big data set where it is like the words are framed in a sentences, and this ML can iteratively understand what to what context the particular word is being used. Like the like we'll not like in other word we can think like ML model is a black box. We'll not be knowing what is happening because it is very complex it is very abstract to understand. So here it understands, we know what it tries to figure out. The things are to where this particular word is being used in a sentence, like avocado or avocat, and based on that it will give some kind of significance to that, like some kind of properties to that, and it will store that word in one kind of dimension, like I showed you, right? The hand gesture, hand digit thing, hand digit data set. So it is placed in like it is placed in some kind of dimension similar to that, but we cannot visualize that dimension. It is very abstract when we look into inner parts of machine learning. As you talked that it can be a combination of regression and sequence prediction. uh, it can be a form, but it is very complex to design such a thing. So one of the easiest and less computationally when we look at computational cost, that time clustering is better option compared to combination of regression and sequence prediction. By the way, I am not sure whether we can use regression and sequence prediction, but we can even look into that perspective. Okay, and I'll be back with that answer to you, okay, later on.
Thank you.
Okay. So
Can I say something here?
yeah. Okay.
Yeah, I feel that the objective of machine learning basically is what will be whatever we are applying, it has to be the most efficient one.
Yes.
So
Yes.
I think the clustering would be the most efficient here
Yes.
rather than regression and sequence prediction.
Yeah. And if we include unnecessary complexity, it is very hard to upgrade it to future
Y-
versions. Like
Yeah,
when
we
you are
won't be able
using,
to maintain it that well or upgrade it or
yes,
otherwise. We can put
yes,
everything
yes,
in something and then make a generic model, which is like in physics, we have that theory of everything, but then something like that, it's really hard to work with it afterwards.
yes. Correct, correct. So yes, we got a clear understanding of this, and I'll be answering few questions which I haven't answered today later on. And we'll go to the next question, that is predicting the quality score of an advertisement. This is a very easy one, and I'll expect everyone to have feel free to have your answer. Even if it is wrong, it is not a problem. Yeah, it's we are here to learn. So as a community. Okay, we have only one answer as of now. So, okay. Yes, fine. Yeah, the answer for it is regression. As you know, this year the quality score can be like in the range of 0 to 100, like percentage, like 97% that it can we can the like 94 97% it can be the quality score. Like it cannot be in a classes, right? That is why it is in regression. So yeah, I think it is an easy one. So I'll move on to the other one. If you have any questions, you can ask me later also. We are running out of time. So I'll be yeah. For this question, yeah, estimating arrival time based on time of day and traffic. So here again it is a regression because the time is in some kind of range. Here we can think as like 1 hour and 5 minutes, which is like 65 minutes. It is in a range of some zero to something. So that is why it is regression. And the last question is translating between two languages. As I mentioned earlier, style transfer, because like we are converting one form of input to other form. So here we are trying to convert some English to Hindi. So that is why we are using style transfer. Along with this, we can even implement a rule based approach to this, but it is very complex in order to convert this same English to Hindi translated application to English to some other version, so some other language like Chinese. So it is very hard to do such a kind of thing. If it is an ML, we can retrain the model with the new data. So that is why we are using machine learning. We can even use the rule based approach for this, but it is very tedious. So the questions are completed. Now let's do a quick review, and I hope you folks to answer these questions. So I like, can you all like raise your questions if you want to answer? The first question, what is ML? So who wants to answer? I know that Vignesh answers a lot, so I will be expecting some other person other than Vignesh. Okay, Varun, yeah, go for it. Answer the question. What is ML? What do you know about ML?
I'm not sure. I joined half an hour late, but what I think ML is, it's like collecting a data set, a huge data set, and then firstly we need to clean the data set, and then you need to analyze it, and then then make a machine learning model out of it. So it's
Yes,
basically analysis of data.
yes, yes. The other meaning for it, it can be like a model, like an algorithm trying to learn some kind of objective from data. Okay. And when we, okay, the next question, who wants to answer? Okay, it's Tarak Ram. Okay, you can unmute and answer what is ML versus rule-based approach.
So in ML, we follow the data and we work according to the data. So we predict the data, predict something out of the data, and then work accordingly. But in the rule based, we follow some particular rules to get a particular thing. Like we don't see the data. What data is it? We won't get particular about the data. Just follow the rules accordingly. We'll do that. But in ML, we'll give importance to the data and we'll change our model according to that.
Yes, it was a good explanation, Tarak
Yeah,
Ram. And
excuse
okay,
me.
yes, yes, you can
Yeah,
say.
in ML, like if you want to improvement, if you want to improve something else, like we should add a data in it, like extra data. And rule based, it's just improving in algorithms.
Yes, improve in algorithms and adding additional rules if
Yeah.
it is required. Yes. So the next question, idea to implementation, like when we saw that machine learning high level view, right? So anyone wants to summarize that high level view in 2 to 3 sentences? You can raise your hand and I'll pick someone from them. So I'm expecting new participants, like new volunteers for this. Okay, we have Puneet, so you can go for it.
So hi, bro.
Yes, hi, hi.
Um, so the basic difference between the three, artificial intelligence is where the technique which enables computer to mimic human behavior, right? And machine learning is like where the technique to give computers the ability to learn without being explicit.
Okay.
And the difference with the deep learning is a subset of machine learning, which makes the computation of multi-layer neural networks feasible.
Yes, it is a correct answer for question 4, but I was expecting for question 3. Yeah, idea to implementation, like from where you start in the ML process. Okay, I'll give an answer for that. So, firstly, you will look for specific users and companies' goals. Then you will create an objective in order to make an machine learning application. Then you will collect the data set. That too, it should be very good and valuable one. It is not necessarily it should be a large data set, but it should be a more suitable towards your objective. Then the third one is train your model, and no, sorry, the fourth one is train your model, and fifth one is deploy it. So, and as we discussed that machine learning is an iterative in nature, we can, like, the machine learning updates itself in online learning, and with new data set, with new like with good data set, it will be improving as time progresses. That is idea to implementation. So the fifth one, history of ML. So anyone who would like to be a volunteer for this?
I just remember three points like it was big data, algorithms, and technology, which were involved in history of ML.
So do you want to briefly talk about these three things? Like, you wish.
Uh,
It's fine if you feel like if it's not required. So I'll tell about them. So in algorithms came like century back. That's the main thing. But because of less computation, like because of no computation, we haven't explored AI at that point of time. The second thing is big data. But at that point of time, even if we had big data, it was low quality data, and we didn't have that much of computation. And the third point is present time. That is technology. Technology has improved a lot. That is why we are benefiting from the applications of AI and ML. Okay, okay, ML. Yeah. So the next one, the sixth one, types of ML. So I'll give a brief explanation about classification. So classification is a type of algorithms which try to classify the objectives. Like when we have cat or dog, so we have classes, right, for that. Then clustering, when we have when we have a group of classes, but these classes are like a combination of different classes. That's when we are using clustering. Because one example you can remember is hand digits, like not hand digits, yeah, this thing, handwritten digits, 0 to 9. So these can sometimes be similar, like 2s and 7. I said earlier, right? So 2s and 7, so that is why we are using clustering here. And like we can even use classification in order to classify one particular class out of 0 to 9. But when we just for example, you can remember 0 to 9 digits, like where they are in some kind of 3D space. And the third thing is regression. So here regression, you can think of some kind of range, like predicting something in 0 to 100. Okay. So the fourth one is sequence prediction. Here best example is your mobile phone, like Google keyboard. So it tries to predict good match to your sequence that you have swiped on your keyboard. And the style transfer, it can be um some kind of image transfer, like trying to change the way your image looks from original form to some kind of modified form. So I have this is
I
a
think I have a good example for style transfer. Like a lot
okay,
of people
yeah,
will be able to understand it like that.
yes, go for
See,
it.
you have that camera filters, no?
Yeah, okay.
That is basically what style transfer is. If you look at
Yeah,
it at
camera filters, yeah, correct.
yeah,
That's the best example.
yeah,
Thanks,
that's the best example possible.
Simon. Yes,
Yeah,
that's the
thank
best.
yeah.
Yeah. So here we are like we are at the end. We completed the slides and the presentation. So right now I'll be expecting like any if anybody has any doubts, we can clarify it, learn together. So if like have your questions in the chat box, or even like you can unmute yourself and ask. Anybody has any questions or anything? And like right now we will be rolling out a feedback form in some due time, and please give us some valuable feedback. It can be some improvements that we need to do, or anything that you feel we should improve, so we can give a best experience in next future session. So here the and Arvind, the DSC lead, is like posting some few links. It is regarding the DSC-ASEB, where you can get access to the all the social media links. And okay, I feel that nobody's having any questions. You can even ask us these questions in this chat below, and we will be giving you all the links that you require, like you have seen, like projector.tensorflow.org, like the handwritten things, and the other links like the YouTube videos that you have seen. We'll be having a Google document that will be giving out to you. You can see that, and it would be like it has keywords and resources, so that would be easy thing for you. So it's a conclusion. Our first day session is over, that is introduction to machine learning. And yes, anybody has any questions?
Hello?
Yes, Tarakram.
Yeah, so do we need to download any software or anything
uh
like
okay, yeah,
prerequisite for this
it's a
schedule?
good question. So you don't require any kind of downloads, because it's everything your hands-on sessions, like the practical application that you will be building, like coding, everything will be online. So you need a Chrome browser and active internet, so you can do everything, like all the setup will be already done for you. You just need Chrome and internet connection. You'll be doing everything in Google Colab. We'll be walking, like we'll be giving each and every segment of the code, like proper explanation will be giving to each and every code.